Okay, so today we're going to talk about one-step equations. We're going to start first with some vocabulary. So in order to do one-step equations, we have to know what equations are, what variables are, and what opposite operations are. So first, let's talk about equations. So equations are two equivalent statements connected by the equal sign. So you can see in equations even part of the word has equal in it. So it's got an equal sign. The two sides should be equivalent or have the same value. Second thing is variables. Variables are a letter or a symbol that represents a number. Typically, what we use is that X. So we know that, X is typical for the variable that we use, but it can be anything. It can be an N or an R or a square, whatever it is, it just represents a number. Opposite operations. We're going to talk a little bit more about this, but basically opposite operations, an operation, typically what we mean is add, subtract, multiply, and divide. And an opposite operation is something that undoes or reverses the original operation. So let's take a closer look at opposite operations. So we look at our typical operations. Our typical operations would be plus, minus, subtract, and plus, minus, multiply, and divide. So the opposite of plus would be minus. The opposite of minus is plus. The opposite of multiply is divide, and the opposite of divide would be multiply. We can look at those a little more closely with some examples. If you take an operation and its opposite, you should end up back at 0. What I mean by that is 3 plus 5 is equal to 8. And then if we reverse that, we start with the 8. We take the opposite of plus 5, that is minus 5, and we end up back at the beginning. We can look at the actual operation itself. If we take a plus 5 and a minus 5, what we do is we end up back at 0. Looking at the next example, 3 minus 5. Remember, this is a keep, change situation. This is a battle. The negative will win. When we subtract the values, we end up with a -2. So 3 minus 5 is equal to -2. If I start with the -2 and I do the opposite of minus 5, that would be a plus 5. We would end up back at 3. So that's what makes them opposites. We can see that again. We can start with the minus 5. The opposite of minus 5 is plus 5, and we end up at 0. Next example would be, stuff is all over the place, isn't it? Let's just look at this. So we've got 3 times 5. Now, 3 times 5 is 15. If we start with that 15, the opposite of times 5 would be divide by 5. And that brings us back to my original of 3. 20 divided by 5 gives me 4. If I start with that 4, the opposite of divide by 5 would be multiply by 5. And again, we end up back at the original. So this is why they're called opposites. They reverse or undo the original. So when we do one-step equations, we're going to go through these steps. If we look at an example here, 2 times x is equal to 12. What we're going to do is we're going to separate the sides. Let me find a different color. So we separate the sides at the equal sign. We want to find the variable. So the variable is this x here. Now our goal is always going to be to get the variable, in this case x, by itself. So that's my goal. So it's the 2 that has to move. So I identify what's happening to the variable. What's happening is we're multiplying by 2. Now, on the last slides we looked at, we know that the opposite of multiply by 2 is going to be divide by 2. I'm going to indicate that with a fraction bar because fractions are just division. And what happens is this 2 divided by 2 ends up being 1, and 1 times x is just that x. So we get x is equal to 12 divided by 2, which is 6. Now, we left off a significant part of our steps in that we have to check. If we check this problem, what that means is that we are going to plug the value we found back into the equation. So 2x equals 12 was my equation. And now I've got this value, x is equal to 6. So I can substitute, meaning replace that x with the 6. And 2 times 6 is 12. So what we get is 12 is equal to 12. Now this is true. If this is true during our checking step, it means that my answer here is correct. So that tells me that x is equal to 6 is my correct answer. Let's look at a few other examples here. So there are our steps. We've got n plus 5 equals 7. We're going to, again, separate the sides at the equal sign. And we do this to make sure that whatever we're doing to one side of the equation, we do to the other. What that does is that ensures that both of the sides remain equivalent. We want to have the value on the left-hand side the same as the value on the right. So we separate the sides, we find our variable. Remember, our goal is to get the n by itself now. Get n by itself. So what's happening is plus 5. The opposite of plus 5 is minus 5. And make sure I do that to both sides of my equation. Remember what we said was plus 5 and minus 5 equals 0. So that goes away. This whole side, the whole mess goes away. We're left with n is equal to, here we have 7 minus 5, which is 2. I can do my checking step. Again, I'm going to replace the variable with parentheses, so that's n plus 5 equals 7. I take this value that I found and plug it in. So I substitute the 2 for the n. 2 plus 5 is 7. We didn't do anything to the right-hand side, so what we get is 7 is equal to 7. And what that does is that indicates that my n is equal to 2 is the correct answer. We're going to do a couple more examples here. We've got, here we go. There are our steps. So again, I separate my sides. I find my variable. I identify what's happening as a minus 3. The opposite of minus 3 is plus 3. And my result is n is going to be equal to -2. Oops. Sorry about that. So in my checking step, sorry, I wrote on the wrong slide. What I'm going to do is I'm going to replace my variable with parentheses. I'm going to plug in this value that I found for my n. I get -2 minus 3. -2 minus 3 is a -5. I didn't do anything to the right-hand side. And so what this tells me is that my n is equal to -2 is the correct answer. All right. Next example. I've got n minus 3, or sorry, n divided by 3 is equal to 9. This could also be written as n divided by 3 is equal to 9. Following my steps, I separate my sides. I make sure I know where the variable is. So there's my variable n. Remember, my goal is to get the n by itself. And when we say by itself, it means that we want n to be alone on this side. So n will be equal to something on the other side. Now, what I see here is that my n is being divided by 3. The opposite of divide by 3 is multiply by 3. So I'm going to multiply the entire side by 3. What this is going to do is it's going to cancel my denominator. 3 times n over 3 will leave me with an n, and 9 times 3 is 27. Now we've got the n by itself. It's equal to the 27, and I'm going to check it. So when I check it, again, I'm going to replace my variable with parentheses. It's important to do this in case something's negative. It just eliminates mistakes. So make sure you're using those parentheses. Inside the parentheses, I put the value that I found, and then I'm going to perform the operation. 27 divided by 3 is 9, which leaves me with a 9 is equal to 9. And that tells me this n is equal to 27 is correct. I have more examples. Here we have an n divided by 9 is equal to 8. Again, I separate my equation into two separate sides. I see that my variable here is the n. The opposite of divide by 9 is multiply by 9. So I'm going to multiply both sides by 9. This cancels my 9's here, leaving me with the n. Multiplying the 8 times 9, that gives me 72. So I'm going to copy my equation again to check it. I'm going to replace my variable with parentheses here. Over 9 is equal to 8, so this was my original equation. I'm going to plug in this value for the n, which makes it 72 divided by 9 is equal to 8. I perform the operation, 72 divided by 9, this is equal to 8, and we get 8 is equal to 8. I think I've got a couple more examples here. Oh, nope, this is a different type of problem that you're going to see, especially in your ALEKS assignments. They're going to ask you to determine whether a value is a solution. And what that means is that they're giving you values for your variable. So in this first case here, it's saying that 2 plus my x is equal to 10. And I'm going to take this value in here, 2 plus 1, this gives me 3 is equal to 10, which is not correct. It's not the same. So my answer would be no. I'm going to do it again for the 7. 2 plus x is equal to 10, plugging in the 7, and I get 2 plus 7 is 9 equals 10. So that tells me that 7 is not a solution either. Last one to check, 2 plus x equals 10. I plug in the 8. 2 plus 8 is 10. So we get 10 is equal to 10, which is true, which tells me that 8 is the solution. Now, you might get more complicated ones. This is actually an example of a two-step equation, but you can always plug values in to see whether they're the solution. So we try 2n plus 1 equals 13. First value to try is the 2. We get 2 times 2 is 4 plus 1 equals 13. 4 plus 1 is 5 equals 13. That is not correct. So we put my check mark on the no. Let's erase this, and we're going to do it for the next value. In the next value, we again use our 2 times n plus 1 equals 13. I plug in the 4. 2 times 4 gives me 8 plus 1 equals 13. 8 plus 1 is 9 equals 13. And again, that's not true. So 4 is not a solution either. We're going to do the 6. We get 2n plus 1 equals 13. Plugging in the 6. 2 times 6 is 12 plus 1. And 12 plus 1 is 13. So 13 equals 13. Shows that this is true. So yes, my 6 is a solution. Now, there are going to be times when you're going to have more than one solution. So be careful just finding the one that works and marking no for the rest of them. We'll talk more in class about when you'll have more than one solution. But for now, on these 1 and 2 step equations, generally if you find a yes, nothing else will work. But let's go through the steps. 2 times 8 is 16. And 16 plus 1 gives me that 17. 17 is not equal to 13, so we're going to mark that one a no.